Yes, thank you. So I just share my screen, right?
Hmm?
It? Yes?
Yep.
Do you see it?
Yeah.
And you see it in presentation view, right?
Yes.
Okay, perfect.
Thank you.
Good. Yes. Yeah, I'm going to talk about generative AI today together with you guys, because I really hope that we can have a discussion afterwards. And I just need to move this one so that I can see what I'm supposed to say. And I think that, or I can imagine that most of you have heard a presentation before about generative AI, since it's all over the place right now. And I would just like to say to begin with that I'm not going to give you any solutions to anything, or give you any directions or strict guidelines, because I think we're in a place right now where we have to figure this out. But just to introduce myself to the ones who doesn't know me, my name is Maiken Westen Holm Svendsen, and I'm a PhD student at Center for Research in Science, Education and Communication at the University of Southern Denmark. I have a background in mathematics and in physics, and from that background, I have an interest in technologies such as large language models or deep learning models. It also makes me an AI fan in the way that I like these technologies, and I like that that everyone now is introduced to them. And we did, or we are introduced to them because OpenAI back in November, not last year, I'm used to saying last year, but the year before that, in 2022, they launched their big app called ChatGPT, which is a large language model. And in only 2 months, they got 1 million global monthly active users. And just to compare it with another app that all of us know, we have Instagram. And here they were 30 months to get the 100 million global monthly active users. And this is not only making ChatGPT the a new app on the digital landscape, but also the fastest growing used app in history, actually. And that is also why my presentation today will focus a bit on ChatGPT, but also just concerning generative AI in a broader perspective. Oh, here we go. But I'm going to divide this presentation today into 2 themes. The first one is what AI is, and also what generative AI is. And then the second part is focusing on how we can implicate or applicate it into our teaching. And the reason why I chose to not only talk about how we can use it in teaching or what we need to be aware of is that I have also attended a lot of these presentations about AI the last year. And I see a tendency towards a misunderstanding of what these models are actually capable of. And just to get a small view into the mathematics behind it, we can maybe get a more real picture of what these models are actually capable of doing. So that's why I'm going to just shortly dig into some of the techniques behind these models. But let's start with that. Artificial intelligence, of course, isn't it's all over the place, and everyone is talking about it right now and has been since the launch of ChatGPT. But it's actually not a new phenomenon. Artificial intelligence is first introduced by John McCarthy in 1956 at Dartmouth College. And he said, in order for something to be artificial intelligent, it has to have 3 properties. The first property is that the technology must be able to adapt and perform as we expect it to do. And that is what he called general learning. The second property is that it must be able to reason, good or bad ways to go, which he called the reasoning competencies. And lastly, it must also be able to solve problems. So I think maybe some of you have, well, everyone has artificial intelligence in their everyday life, but I think maybe just to give you an example, you can imagine the robot vacuum cleaner at your house. So if you're looking at a robot cleaner, we expect it to vacuum and to clean. So that's the main purpose of this device. And when it is moving, it can reach an obstacle, and then we would expect it to know if one way is better to go around or the other, otherwise it would turn around and go the other way. So we would expect it to reason, which way am I going to deal with this obstacle? And of course, if it gets stuck, because all of these vacuum cleaners does at some point, we will expect it to solve the problem. Again, it's only a vacuum cleaner, so the way that it's solving the problem is that we get a notification on our phone saying you're going to vacuum your house yourself when you get home because I'm stuck somewhere, right? And that's, yeah, great, of course. Yeah, but that's a broader description of artificial intelligence. And looking into these large language models, we are only concerning a subgroup of artificial intelligence models called deep learning models. And even further going into that subgroup, we have what we call a neural networks, which is the technologies behind these large language models. The way that they are actually working is that it is a neural network. So it is neurons, and they are somehow linked together. So I've just tried to give you a visual representation of my own neural network, or not my neural network, but yeah, someone that I just draw. And the neurons is the nodes on this graph. And the links between them, the edges, is called parameters, and that's how they are linked. So neural networks is actually inspired by the neural networks that we have in our brain, and that is also why we call it artificial intelligence. And this neural network, as we see here, is just what we call plain vanilla. It has no frills, it has no features to it. It's just nodes and edges. Inside these nodes that we call neurons, we have a number. And I will just see, oh no, it's not yet. Okay, so we have a number, and that number is what we call an activation. And how it works is that if you get an input in the input layer, it could be that, okay, so I'm just trying to set up an analogy here. So if you're imagine a band on stage and you're at a concert, you would maybe at some point during this concert, of course, depending on which kind of band, have someone saying, play something with Slayer, right? Yeah, and that's the input for the band. And then these activators is going to respond to that input. And in the case of a band, that would be maybe the drummer setting a beat for a Slayer number or a Slayer track. And when he's doing that, that's the first hidden layer being activated. This hidden layer, the drummer, is now trying to communicate to the bassist what he is supposed to do. And he's trying to give another layer on the music such that it is a Slayer track coming out in the end. So he's trying to say, okay, I'm going to play something with Treya together with this rhythm. So how can I do this? And that's the same for the rest of the hidden layers of the musicians. And in the end, we have the last key. And then hopefully we would have something with Slayer. So let's look at this in a mathematical way now. So we have, so every time we do that, we are, so we have the input. And if we're just looking at one node here, one activation, we have, in order for it to be linked with the first hidden layer, we needed to go by one of these 4 edges. And these edges, as I said before, is called parameters. And every parameter is weighted. And that's why we have these W's. So it's just how much does it cost to go this way in order to get into one of the nodes in the, or the neurons in the first hidden layers, which has an activation. So what we do mathematically with this is that we take every corresponding activators with the weight and we multiply them. And then we take all of the activators and the weights in the corresponding to the first hidden layers, and then we add them. And now we are using what we call a squishing function called the sigmoid function in order to get a number between 0 and 1. Minus a bias that makes us get rid of all of the nodes not containing anything that we has something to do with Slayer. It could be jazz or country or I don't know, and we will get rid of them. And then in the end, we should have new activators that we should take one by one into the next hidden layers. And this is done for every node in every layer in order for us to get an output in the end. Okay, so if we're looking at ChatGPT, and this is the 3.5 version, which is available for all of us, we can see that we don't not just have 4 layers as I had in my little neural network, it has 96 layers. And the neurons in the input layer can be up to 4,000 neurons. Of course, when we are looking at ChatGPT as a technology, it is trained on a set, it is trained on some data, which is just the internet, which has over 500 billion tokens, we say. And the edges in between, we have 175 billion edges also. So I think this maybe combining with the explanation that I just did before, you can see that in order to give it just one output, there is a lot of calculations in there. And it's something called tensors that is been used but I will not go deeper into that. But it's just to give you an expression of how many calculation is done in order for you to get an output in the end. And of course, there is some limitations. I said that it is trained on the internet, but the internet can be a bad place also. So there are some limitations, which is scripted into these models in order for ChatGPT to not type or give an output that is not ethical. So it's not able to do hate speech, illegal activities, medical or legal financial advice either. And so that's some limitations that ChatGPT prompt or scripted into their script that it's not allowed to give answers to. But there is also some limitations just by looking at the model itself. So one thing is that it has no knowledge. So it has a knowledge cut off in 2021. Of course, it's been through updates and some more knowledge came in. And again, oh yeah, one thing I forgot to say is that the way that these new networks works is that it is the path that is chosen is the most likely, of course. So it's how, so it also has to do with properties and statistics, and it takes the most likely path through this neural network to give you the output. So it also means that the most likely is also what's most representative or represented in the internet as well. And that is also why you can sometimes have biased output or some misinformations to some of the questions that you are prompting to this model. And just the pictures over here is that right now there is a trend trying to play with these limitations, not only in the language models, but also in picture generating generative AI models. So we have these small teddies over here, and there's a trend right now saying that you should, yes, make them even more happy or make them even more happy. And you'll get the picture down here in the end. So it's just, everyone is right now trying to figure out the limitations and what these models are actually capable of. Oh, yes. Okay, this was just to give you a brief introduction or understanding of how these networks are actually built and designed. And now we can look into my second part, which is about how we integrate generative AI in education. And this is a big question mark. It is actually a small question mark on the text, but it should be a big question mark because many institutions have discussed this during the last year. Some has developed some guidelines, some are on their way. But there are so many things to this question that we don't know yet. Also ethical and philosophical questions. And yeah, this is still just a big question mark. So when we have questions in research, we tend to look at the literature. And right now, at the moment, there is a lot literature out there dealing with generative AI and ChatGPT, of course, but they are mostly dealing with the capabilities of these models. How can we use it in order to give suggestions to the teachers or in an assessment process or something like that. But there is not a lot. I think I found 10 studies which were actually empirical studies or case studies on how does these models affect the students' learning. So there's a high need for more empirical research and case studies on this field. But one thing that we, so one question that we could ask is when to integrate generative AI. And the studies, of course, suggests that we can do it in students' work. So when they're working together in groups, doing projects where they are mostly on their own. We can also do it into our teaching. So we as teachers can do it or use them as a tool to plan our lessons. And we can also do it in examination situations. But this is also a big question because then we run into something with plagiarism that I'm going to talk about later. And so this is also a big question. So how can we do it in examination situations, should we just ban them? Or yeah, so there are a lot of questions. So when there is so many questions and not that much study on it, or experimental study at least, we can maybe look into some other theories regarding introducing technologies into our educations. And there is some theory by Drivers from 2013 called instrumental genesis. Also, Peterson and Järnqvist has worked on this instrumental genesis, relating it to CAS tools in mathematics education. But the theory is concerning three dualities. It is the first one is the artifact and instrument duality, which describes that when ChatGPT as a technology is firstly introduced to students, it is a new and unfamiliar tool. And when you're using it, it will evolve into a more tailored academic resource that you can actually do or use in a constructive way. The second duality is instrumentation and instrumentalization. So we have that ChatGPT first is shaping the student's understanding towards a certain theme or some knowledge, but is evolving into a technique or an instrumentalization where the student's knowledge can also guide the way that we use ChatGPT. So the testing the limitations is a good example of this. Then we also have the last duality, the third duality, being technique and also scheme. And then to begin with, the students, when we're looking at them, we can see that they're showing visible actions in how they use ChatGPT. We can see them prompt something. We can see maybe they're reading it, maybe they're copy pasting or something like that. But it will develop into a more cognitive process scheme, how we can actually use ChatGPT and what we can use it for. And it's going from visible actions to more or less something that's inside the brain, cognitive affected. Yeah. Oh, yes. Oh, sorry. I was too fast. No? Oh, yeah, it was right. So one thing that I think is interesting looking into this theory is that what the role of the teacher is in guiding these students in the process of integrating generative AI, looking into these three dualities. So the teacher's role in order for make ChatGPT going from an artifact to an instrument is, of course, to introduce it. And then is encourage always explanations on why are we using it, what are we using it for, and so on. And integrate it not all at once, but gradually. Firstly, maybe it could be in problem solving, maybe it could be searching for concepts that you don't understand when you're reading in your book, and so on. In order to make ChatGPT or generative AI going from an instrumentation to an instrumentalization is to guide a thoughtful interaction and encourage all the time to be reflective. So this is quite similar to the first one, but it is important that they really encourage that why are we using it in this way? Is the answer that we are receiving from these bots actually correct? And how can we verify the answers that we get? And how can I use my knowledge in order to give better prompts such that we give better answers? Yeah. And the last one, in order for it to go from technique to a scheme, is to teach them effective techniques. How should we use these? Is it okay to just copy paste, or should we actually read the answers before maybe using some of it or learning from it? In order to foster cognitive development, of course. But one thing that is really important in this process is always giving feedback and encourage reflection. Okay, so that was in the case of the two first scenarios where we can integrate it in study work, group work, and of course in teaching. But in relation to the exams, we have a huge problem because Akademibladet did a survey or an inquiry in 2023, last year, and they saw that every 10th student cheats at the exam using generative AI in Danish preliminary schools. Yeah. So how do we deal with this? Of course, we need to discuss and make guidelines where we consider plagiarism. So we need to define or redefine what we see as plagiarism and academic dishonesty. And it also makes me question whether this is the end of written exams, maybe. So it could be that we see a shift towards more authentic assessment. And of course we also need to think about whether or not we want to assess knowledge or competencies, which is more action-based. And these two last points is actually something that's been interesting in assessment research for many years, but it seems like the policy level has difficulties to imply or implicate it in, or make assessment that concerns with these two things. And maybe ChatGPT or generative AI in general is maybe the reason why to actually take this serious and try to do something with the way that we assess our students. But one thing that is really important thing is that we as teachers and of course as researchers doing teaching need to engage with these models. Otherwise we have no way of helping our students navigating in using these models, and we have no way of determine whether or not to do with it. Yeah, and that was my last point. And then Gitte asked me to prepare 2 questions. The question that I think that we could maybe do in the breakout rooms is that, or talk about in the breakout room, is that what are the long-term consequences of integrating generative AI into our educational system, and how do we prepare students and teachers for a future where AI technologies are pervasive? That's 2 questions in one, I know, but yeah. The last one is that what kind of policies and guidelines and regulations are necessary to govern the use of AI in STEM education?
Thank you very much, Maiken. Yeah, and we can just put them in the breakout rooms and in the our chat. So if you will just